solving with double angles. In this presentation, what we want to take a look at is what happens when we take a trig function and we're not just taking it of just the x or whatever the variable is, but what happens if we have a 2x or possibly even a 3x? How does that actually change our answer? So I'm going to work through two examples in this scenario to talk about, all right, how do we go about finding all the solutions given that we have a double angle? Another thing, in this first example, we see that we have some like eye candy that maybe makes this a little bit intimidating. We see that we have some pies. But again, don't panic too much. This is pretty simple if you just go ahead and isolate the trig function. Tangent of 2x, right, stays on the left with the pi. I'm going to subtract pi to both sides. And then I'm going to divide both sides by pi. So therefore, I get tangent of 2x is equal to -1. So even though there were some pi's in the beginning, they all reduce each other. And now I got a nice basic statement that says tangent of 2x is -1. So if I take a look at this, I'm going to treat 2x just like I treated x previously. And what I mean by that is I'm going to say, all right, tangent is negative in quadrants 2 and 4. Based off of it being negative, I know I have a -1, 1, this is square root of 2, or in other words, my reference angle is pi over 4. So now here's where the catch comes in. Instead of me saying x equals 3 pi over 4, I say 2x equals 3 pi over 4, and 2x equals what's going to be 7 pi over 4. Now, let's make sure we remember in our previous instructional videos, we are finding all solutions. So what I have in this case is I'd have to put that plus 2 pi k plus 2 pi k, representing all those coterminal angles. But we also understand that this simplifies to 3 pi over 4 plus pi k. And again, that's because we're rotating half a rotation to get each one of those new solution angles. But we're still not done. Let's clean it up a little bit. Remember, we have 2x equals 3 pi over 4 plus pi k. We didn't solve for x just yet. But in solving for x, we're going to divide both sides by 2, which means I divide both terms by 2, giving me 3 pi over 8 plus pi over 2k. So the only new step that we have is we get to this same component that we got in our previous videos, but we have to divide by that coefficient to get our final solution set. So using that, you can make a prediction on what you think the answer to the next one's going to be. And if you need to, feel free to pause the video, but I'm going to move forward as if you already had a chance to try it. So in this case, what I have going on is I see that I have cosecants, so I'm going to factor out the cosecant x, and that's going to leave me with cosine of 3x plus 1 equals 0. So now at this time, I can apply the zero product theorem. I could say cosecant x equals 0, cosine 3x plus 1 equals 0. I want to go ahead and isolate my trig function, so this is going to be cosine of 3x equals -1. Now, in this case, if we go to try to understand what's taking place, cosecant is r over y. So again, the radius is always a measurement. So there's no way r can be equal to 0. So there's no way cosecant can be equal to 0. So this doesn't have any solutions. So I don't get anything from the first factor. There's no solutions from here. Now if we go over to our next portion, cosine -1, well that tells me I'm going to be right here. Because again, this is x over r. So the x component would be a -1, the radius would be a 1, hence we get the -1. So now we get 3x equals pi. But this is a little bit nicer in this case. We're going to divide both sides by, oops, don't forget, plus 2 pi k. And then we get x equals pi over 3 plus 2 pi over 3 k. So with these scenarios, and we identify them early on, we see that if we have a multiple angle, what's going to end up happening is we have one last step, and make sure when you do that, that you divide the portion here as well. Don't forget to divide that coterminal expression by the coefficient that's in front of the x or whatever.